So in the last lesson we looked at electromagnetic induction. So this lesson we'll look at ways that we can use electromagnetic induction in our everyday lives. And an example of that is electromagnets. An electromagnet consists of a current carrying coil or solenoid wrapped around an iron core. Here's an example here which you can do in the laboratory. We have an iron core, in this case a nail, and the battery obviously is attached to the wires. You can roll the wires around the coil, and what you've done is that as soon as you induce charge, that forms a magnetic field around the solenoid, which can then induce magnetism in the iron nail. And there's an example there. So continuing on in the use of electromagnets, an example is a scrapyard crane. So when you turn the current on, you can generate an electromagnet. In this case, the iron core of the electromagnet is a soft magnetic material, which we dealt with in the first lesson on electromagnetism. And when current flows, the iron becomes strongly magnetized due to the magnetic field induced in the wire, and so picks up the scrap iron and steel. And when the current is turned off, the iron loses its magnetization and so releases the metallic scrap. So another example is the electric bell. So when you push the switch is closed and the current flows around the circuit, turning it into an electromagnet here. Okay. The soft armature or iron armature is then pulled towards the electromagnet and the hammer hits the gong. This causes the contact switch to open, cutting off again the electric current, and so the electromagnet turns off. The spring now pulls back the armature and closes the contact switch, and so the cycle begins again. Its current now flows again and the hammer hits the gong again. Let's go through it again, see the animation. Current flows, hammer hits the gong, goes off. Okay. Another example is the relay switch. A relay switch is a way of using a low voltage circuit to switch remotely to a high voltage and possibly dangerous circuit. Okay, so when switch A above here is closed, the small current provided by the cell causes the electromagnet to become magnetized. Therefore, the iron armature is attracted to the electromagnet caused around the current flowing in the solenoid, and the springy contact switch B closes in the high voltage circuit. So again, okay, and therefore the high voltage circuit begins to go. This induces the closing of the opening up of switch A, and again the same issue happens. Not until switch A is turned on do we have the ability of the relay switch to actually function. And the final example is a circuit breaker. So current normally flows between terminal A and terminal B here through the contact and the electromagnet. Here we go. See, you've got current flowing. It goes to the electromagnet. It obviously induces current and induces a magnetic field. So when the current in the circuit increases, the strength of the electromagnet will also increase. This will pull the softer iron armature towards the electromagnet. Okay, as you can see, it starts to move. As a result, spring 1 here pulls apart the contact and disconnects the circuit immediately and stops the current flow, as you can see here. Okay. The reset button can be pushed to bring the contact back to its original position to reconnect the circuit, and here's an example here of a domestic circuit breaker. Okay, so just to finish off the lesson, here are a series of words. I want you to pause the video and see if you can fill in the gaps, and then we'll go through it together to see if you've understood the lesson. Right, so a wire carrying an electrical current produces a magnetic field. The field increases in strength if the current is increased. A solenoid is a coil of wire carrying an electrical current, and the field produced increases in strength if the number of turns in the coil is increased, or if iron is placed inside the coil. An electromagnet consists of a coil and a solenoid wrapped around an iron core. And iron is a soft magnetic material that loses its magnetization once the current in the coil is switched off. So just finally, here are a few websites which you could be interested in to further your understanding of electromagnetism.